Hi guys, how are you? Today we will do the structure elucidation of the quinoline. As you may see, this is the structure of the quinoline. This is the very important structure, and as you may see, this is the proton NMR. Proton NMR of quinoline. And these are all the peaks of the protons that are present in the quinoline structure. The protons that are present in the quinoline are as one proton is present here. See, one proton here, one proton is here, and one proton is here. No proton is present here and no proton is present here because the carbon valency is fully satisfied here, as we here carbon has the total 4 valencies fully satisfies with the other 4 carbon atoms, and same here the carbon is fully attached with the other 4 carbon atoms, and the one proton atom is attached here. Similarly, one proton is attached here and one proton is attached here and one proton is attached here. So if you count the total protons that are present here, this is the 1, 2, 3, and this is the 4th one, and this 5th, 6th, and 7th. It means that in the quinoline total 7 protons are present. So the number of the peaks that should be present here should be 7. And now it should be 7 protons are present. Now we should find the protons that are of the same chemical shift value, as this is the benzene rings of the total 2 benzene ring, but the problem is that there is the one heteroatom of the nitrogen present, and if the nitrogen heteroatom is present, then the problem is this will affect the hydrogens that are present here, as this nitrogen it has the auto effect with this proton atom, so it will affect this, and the para effect with this proton, and it will affect here this proton also, and automatically this will affect also this proton somehow. And similarly here, no proton is present, no proton is present here, and this will affect also somehow this proton and somewhat this proton. So these all the protons will not have the same chemical shift value same exactly, but somehow they will have the close chemical shift value. So they will have the very closely present in the proton NMR, but they will not have the same exactly same and will not show the exactly same peak with the same chemical shift value. Will with that can show us the integration value of the 2 or the 3 with the same chemical peak area. So now as you may see here in the proton NMR spectrum, that if you count the number of the peaks, this is the here 1 peak, 2nd peak, 3rd peak, and here 4th peak, 5th peak, and here 6th peak. Okay, so the protons are 7 and the peaks are 6. 1, 2, 3, 4, 5, and 6. But the protons are 7. And now if you see here, there are the 2 protons, 2 peaks that are of this not exactly of the same chemical shift value, but they are of the very close, that they are very close to merge each other. Not exactly of the same, that they are coming of the same chemical shift value. As you may see here that this is not of the very high resolution NMR spectrum, but they are close to merge each other, but not very high. So in this range, 2 peaks are close to merge each other. So I may say here that in this area, 2 peaks are close to merge each other, and we are finding here in this area here, not very close, but we can find from here. So now the problem is that we have to find the quinoline structure from this value. Okay, how do we find that this is the structure of the quinoline? Actually, if you see here, this is the 7th chemical shift value, and this is of the value of the 9th chemical shift value. But the benzene will always show 7 to almost 8.4 or 8.3, or in some books 7 to 8 range of the chemical shift value. And in these values, it is showing the 7 to 8 ppm values, but here these 3 to 4 peaks, these are showing above the 8 ppm shift values, and this is because the nitrogen is present in its neighbor. When the nitrogen is present in its neighbor, what it do? Actually, the nitrogen is the electronegative atom. Whenever the nitrogen is present, it is what it do. It withdraw the electrons toward itself. When it withdraws the electrons, then the carbon atom deshielding, and this deshielding effect also withdraws the electrons from the carbon hydrogen bonds towards itself, and the hydrogen here becomes the deshielding, and these hydrogens then becomes the, so that was the chemical, that was the structural elucidation of the quinoline. If you like my videos, then please subscribe my channel. I hope you have understood it.